Motion under gravity. You see that constant acceleration formula that we just discussed. When it comes to motion under gravity, there is a little pepper and Maggi added to it. Small thing change inside. When gravity is involved, small thing change inside. And what is that small thing that change inside? Let's see. Acceleration due to gravity, g, this small letter g, is approximately 9.8 meter per second square downwards. So the force, the gravitational pull downwards by the earth, the speed or the acceleration that the earth used in pulling any object that goes up downwards, that force, that gravitational force applied to any object that goes up, is at 9.8 meter per second. So that object descends at this velocity. Any object, it descends at this velocity. This is the maximum velocity that object can descend in. Okay, the maximum velocity. You know that the moment an object drops from a height, the more distance it goes, the faster it drops. The more distance it covers, the higher the acceleration. Okay, so as the object continues to descend, the acceleration gets higher till the object hits the ground. So acceleration continues to increase until the object hits the ground. So the maximum acceleration of an object which is being acted upon by gravitational pull is 9.8 meter per second square. And what are the equations? Okay, the equation for motion under gravity. The equation for motion under gravity is almost the same with equation of motion. Okay, equation of motion at constant acceleration. But the difference is just that, you see, anywhere you have acceleration, change it to gravity. That's the difference in the formula. If you look at this one, v equal to u plus gt. We are supposed to have a here is gt. S equal to ut plus half gt square. We change this a to g. V square equal to u square plus 2gs instead of 2as. It's very easy. It's very easy. So anywhere you have a, just put g, or anywhere you have acceleration, put gravity, because we are calculating acceleration due to gravity. The gravity now represents the acceleration because is this constant maximum acceleration, which is 9.8 meter per second, is constant. That's what you use in solving acceleration due to gravity. Let's look at this example on the right hand side of the screen where we have the blue table. Example: a stone drops from rest. Initial velocity equal to 0. That's from rest. Falls 20 meter. This one is the distance covered. So if we want to calculate the acceleration due to gravity, what are we supposed to do? Since we were given initial velocity and we want to calculate acceleration due to gravity, it is better we use this formula. Okay, we use this formula because we want to calculate the acceleration due to gravity. Okay, we use this one because it's the distance covered by the object due to gravity we want to calculate. So it's this one that we are going to use. So what do? Since we have observed and we have seen that we were given distance, which is s, and we're also given initial velocity, which is u, and we have gravity, this formula, the second formula of this acceleration due to gravity, is the perfect fit for this question. So what do? We substitute. Okay, so s, because what we are looking for is the acceleration due to gravity. Okay, and that is approximately the time taken. The time taken, that's what we are looking for. So we are going to say s equal to ut plus half gt square. So s is the what? The distance, and 20 is the distance here, 20 meters. We input it there, we substitute everything. Initial velocity is 0.5. We are looking for time. Time will be there, t, times half gravity. Half of this gravity times t square. When you solve this basic mathematics, you get your answer. 1 times this over, you are going to get 4.9. Then 4.9 times 0.5, divide both sides by 20. When this t square crosses equal to side, it becomes square root. So it will now be the square root of what you have from here. That's going to be the answer. Graphical interpretation. Graphical interpretation as regards acceleration, as regards velocity, and as regards distance. That's what we are looking at here. Jamb loves repeating questions from this graphical interpretation. The first we have here is distance time graph. And interpretation of graph is very easy. All you have to know is the principle. So when you say distance time graph, it means that distance was plotted on the left side of the graph, then time was plotted on the right side of the graph. Or distance on the y-axis of the graph, time was plotted on the s-axis of the graph. That's the horizontal axis. So we are looking at distance covered with time. At a particular time, what distance was covered? At a particular time, what distance was covered? That's what this graph is interpreting. So what you have to note is the slope is equal to the speed. So the slope of a distance time graph is equal to the speed. So if they say calculate speed and you see slope there, pick slope because slope is also speed. Straight line equal to uniform speed. The straight line in the graph, okay, after plotting the graph, the straight line there is equal to what? Uniform speed. So if they say look for uniform speed and what you could find or what was given, you can find the straight line there. You pick straight line as uniform speed. The next interpretation under the distance time graph is curve. Curve is equal to accelerated motion. So the curve, we already said the straight line of the graph is equal to uniform speed. That's the uniform speed. Then the curve is equal to what? The accelerated motion. That curve is equal to the accelerated motion. Let's take a look, please. Velocity time graph. Interpreting velocity time graph, the slope is equal to acceleration. Unlike the distance time graph where the slope is equal to the speed, in velocity time graph, slope is equal to acceleration. Okay, so the slope of the graph is same as acceleration. So if you are told to find the acceleration of the moving object in the distance time graph, what do you have to do? Just look for the slope and you get the acceleration. Or you are given acceleration and you are told to look for the slope. Just use the acceleration to get your slope, because the slope and acceleration is the same. So the acceleration is the slope. The acceleration is the answer. Or if you are given parameters to solve for acceleration and you are told to look for slope, you solve acceleration and give the answer as your slope, because the slope is equal to the acceleration. Then the area under the graph is equal to what? Displacement. That area under the graph is equal to displacement. Let's take a look at the velocity time graph. Instantaneous velocity and acceleration. What are they? Jamb wants you to know this. So when you say something is instantaneous, it means that that thing is sudden, instantly. Instantaneous velocity at a specific instance is equal to slope of tangent to displacement time graph. Listen, velocity at a specific instance, that is the principle of this instantaneous velocity. Velocity at a specific instance, velocity at a specific time is equal to slope of the tangent to displacement time graph. Number one. Then number two, which is the instantaneous acceleration. Acceleration at a specific instance, which is acceleration at a specific time, is equal to the slope of the tangent to velocity time graph. Instantaneous velocity is to displacement time graph, while instantaneous acceleration is to velocity time graph. Have that in your mind, never forget that. Now that we have understood acceleration, velocity, displacement, and so on and so forth, let's now test the knowledge we've acquired so far with some Jamb must repeat questions. Jamb must repeat questions. Question 11. Which of the following is an example of oscillatory motion? A car moving along a straight road. B, a spinning ceiling fan. C, a pendulum swinging back and forth. D, a ball rolling down a slope. Drop the answer in the comment section. Question 12. Which statement is correct? A, speed and velocity are both scalars. B, speed is scalar, velocity is vector. C, acceleration is scalar, velocity is vector. D, speed and acceleration are vectors. Drop the answer in the comment section. Question 13. A body starts from rest and accelerates uniformly at 4 meters per second square for 5 seconds. What is its final velocity? A, 10 meters per second. B, 15 meters per second. C, 20 meters per second. D, 25 meters per second. What's the answer? Drop the answer in the comment section. Question 14. A stone is dropped from a height of 45 meters. Take gravity equal to 10 meters per second square. How long does it take to reach the ground? A, 2 seconds. B, 3 seconds. C, 4.5 seconds. D, 5 seconds. Drop the answer in the comment section. Question 15. On a velocity time graph, the slope of the graph represents what? A, speed. B, displacement. C, acceleration. D, momentum. Drop the answer.